Hello everyone. Good morning. This is Ajay Babu, working as an assistant professor in Marri Laxman Institute of Technology and Management in the Department of Mathematics. So today we are going to discuss about differential equations. So differential equations we are going to discuss, which is first BTech second semester. The students are going to learn this one. So in that, first before entering into the exact syllabus, first we'll see that basic things. So what already they know that. So here it is in this particular first unit is first order ODE. ODE is nothing but ordinary differential equations. In that first we'll see that what is meant by differential equation and next types of differential equations, and after that we'll go for ordinary differential equations, exactly what they have the syllabus in this semester. Okay, and coming to differential equations, in general day-to-day life we use these differential equations like as suppose in here Newton's law of cooling, population, natural growth and decay. So Newton's law of cooling is nothing but generally we can say that in here it is having like morning we take it as a cup of tea. So at initial time what about the temperature, after certain time how the temperature, so it is depends on the differential equations we use that one. So Newton's law of cooling, in the same way population growth in particular year how much it is, and next how much it is reducing or increasing. So that's all these things simply we say that applications of this one. And here it is, after completion of this particular unit, the student will try to learn that first he will identify that given differential equation is which type, so coming under linear or non-linear, and based on that particular which one is suitable for that solution may apply here. So this is the one. So we are first will see that ordinary differential equations. In that first one, what is meant by differential equation. So before going to that, first we'll see that what is meant by dependent and independent. So this is very well known. Generally, if you are taking our family, there it is simply will say that independent persons are there as well as dependent people are there. So generally father is a independent one and mother and rest of the one will say that dependent one. So here it is also same thing. Here if we are saying that the function, so y we'll choose generally as y equal to f of x. So here y is nothing but dependent on x, right? So here we called as x is a independent variable and y is a dependent variable. So here d representing nothing but derivative. So the derivative is nothing but the rate of change. So that only we write dy by dx. Always we represent the derivative is nothing but in that y is representing dependent variable and x is a independent variable and d representing derivative. And it may change also if you are choosing x is equal to f of y. In this also x is dependent and y is independent one. In that case we'll write it as dx by dy. So dx by dy will write in this case, right? So based on this, so with respect to how every time we apply independent variable. So here first you see the definition of differential equation. So an equation in the name only itself equation, right? An equation involving a dependent variable and its derivatives with respect to one or more independent variables, then we call that equation is a differential equation. So in the name equation first we are saying in that equation what are the things has to be there, dependent variable, independent variable and derivatives, and that independent variable one or more. So then we say that that is a differential equation. Like so here what we said, see here if you see this equation dy by dx plus 7xy is equal to x square. In that differential, can we say that this is a differential equation or not? So here it is having dependent variable is there y and independent variable is x, but here it is having only single independent variable, right? So this is differential equation. In the same way if you come into this one also, here it is having two independent variables x as well as y, but dependent variable is here it is having z. So dependent variable is one and independent variable is more than one, the also that is also coming under differential equation. So differential equation is nothing but an equation involving a dependent variable and its derivatives with respect to one or more independent variables is called a differential equation. Next, types of differential equations. There are two types of differential equations based on the independent variable. So based on the independent variable, we are dividing the differential equations into two types. One is ordinary differential equations and second one is partial differential equations. This is just for understanding purpose. So simply if you are taking that, the difference is for, if you go for previous generations like our grandparents, like in that case, there if you see that ordinary families generally will say that there it is having one independent person, either it may be grandfather or grandmother, like that, and rest of all the people dependent on that person. He will take the decisions, everything, right? So that is, if you see that their independent person is only one, right, and rest of all the people just you can consider as one thing, that is dependent variable. So it means simply we say that an equation which is having only one independent variable, then we call that is a ordinary differential equation. So ordinary differential equation is nothing but, this is also a differential equation, but in this differential equation we have one dependent variable and only one independent variable. Here we give two examples. Here it is, if you see that dy by dx plus 7xy is equal to x square, and second one is d square y by dx square plus 3 dy by dx plus 2y is equal e power x. In that only one independent variable, right, that is nothing but x, and dependent variable is only one, that is nothing but y. Next, coming to the second one, partial differential equation. So partial differential equation is nothing but, we can say about present generation. If you take it as a small family, in that wife as well as husband both are independent, they are earning, right, so they take the decisions individually, and the rest of the children are what in their family, that one we can treat as a dependent one, right? So in that partial, it is some like, okay. So partial differential equations are nothing but if the independent variables are more than one. So independent persons are more than in family, then obviously the some partiality, some clashes, like so, like that. Simply this is just for understanding purpose, not more than that. So partial differential equation is nothing but, here it is, the thing is more than one independent variable. If you see that these differential equations, what we give, dou z by dou x whole square plus dou z by dou y whole square is equal to 4z. Here if you see that z is a dependent one and x and y are independent, two independent variables, more than that also we have. So partial differential equations means more than one independent variable. Here we have two independent variables, x as well as y. And next, coming to the second example, if you see that here also we have two independent variables, right, x as well as y. So this is one independent variable, this is another independent variable, and z is a dependent variable. So this is about classification, or simply say the types of differential equations. The thing is only one. Ordinary means one independent variable, and partial means two independent variables. Two, not only two, more than one. So either it may be two, or it may be three, or it may be four, more than that. More than one, simply will say that that is partial differential equations. Next we are going to see the definition of order. So order of a differential equation, that may be ordinary differential equation or partial differential equations. Here we are going to see that the unit only ordinary differential equations, that's why we discuss about only ordinary differential equations. Okay, so order is nothing but general way, who passes the order, so who is having higher authority, right? So higher authority is nothing but, here also same thing, if you take the differential equation which is having the highest derivative, then we say that that is a order of that particular differential equation. Generally what we are saying, y is equal to f of x. Here it is having, if you are applying one time derivative is nothing but dy by dx. If you are applying two times derivative is nothing but 2 times d square y by dx square, 3 times d cube y by dx cube, 4 times d power 4 by y by dx power 4, and n times d power n y by dx power n. So it means that in the equation which one is having the highest, then we say that that is nothing but highest derivative is appearing in the equation, that only will say that the order. So that only here it is the order of the highest derivative occurring in the differential equation, order n, if the nth derivative is the highest derivative in that equation. So which one is having the highest derivative? that only simply will say that order of that particular differential equation. If the differential equation is having nth, suppose the given differential equation is having nth is the highest derivative, then nth is the order of that particular differential equation. Let us see here, we give the examples. First one, if you see that x square plus 1 dy by dx plus 2xy equal to 4x square. So here it is having, we are up the derivative, if you see that the equation dy by dx. So this is the ordinary differential equation, one dependent variable y and one independent variable x. So this is nothing but ordinary differential equation, and the highest derivative in this equation is nothing but dy by dx. So it means here it is having only 1. So that is the order of the differential equation is 1. Next, come into second example. If you see that d square y by dx square plus 5 dy by dx whole square plus 2y is equal to 0. So in this equation, if you see that, so which one is the highest derivative here? So d square y by dx square. Of course, here dy by dx whole square, but here dy by dx is representing as first derivative. And if you see that d square y by dx square is nothing but 2 times derivative we are applying. So it means simply first class, second class. So which one is better means second class, right? In the same way, here it is having first dy by dx is having only one of first order, and d square y by dx square is nothing but second order. We don't bother about the powers, how many it is. Okay, we need to see that only the derivative, how many times the derivative is there. So that only we need to see here. So d square y by dx square is nothing but the order is 2. And next, coming to see the next example, also same like that, x into d square y by dx square minus 2x minus 1 into dy by dx plus x minus y 1 into y equal to e power x. So here if you see that, so here also same thing, dy by dx we have and d square y by dx square also we have, right? So here the order is obviously 2. Why? Because the second order only appearing in the equation, this is the first order. So order of this differential equation is 2. Is it clear? So order is nothing but highest derivative appearing in the equation. So we don't see that, suppose here it is having dy by dx whole power 5 also, we don't bother about it. Why? Because we require only the highest derivative. So d square y by dx square is the highest derivative. So further the order is 2. Next we will see that degree of a differential equation. So this is order also we require, and based on that degree we will write. So here if you see that the definition, degree of a differential equation is the highest degree of the highest derivative. It means first we require the derivative. So highest derivative we require, and that derivative highest degree. If suppose in the equation having highest derivatives are 2 parts, but in that which one is the highest power, right? Suppose if you see that in the college or somewhere 2 people are there, but highest power is which one having that only we'll see that. So in the class all the students are there, but the leader class is the class leader is the top, right? So that like that here also same thing, derivatives so many in that, but in that highest power. So power is the mandatory here. Is the in the equation, after the equation is made from radicals and fractions in its derivations. So fractions, if it is anything we need to simplify that one. Any roots like that also we need to simplify. After simplifying that, we need to give the conclusion about the degree of that particular equation, as well as order also we can write. Let us see the example here. It is having y is equal to x into dy by dx plus square root of 1 plus dy by dx whole square. This is the given differential equation. We should not say that directly the degree of this equation. Why? Because here it is having square root. So first we need to eliminate that square. So for that we need to do some simplification here. So simplification is nothing but, suppose here it is having, so first you take that term into left side. So there it is having plus, when it comes to this side it changes to minus, right? Y minus dy by dx is equal square root of 1 plus dy by dx whole square, right? And next squaring on both sides. So squaring on both sides, then we'll get y minus x dy by dx whole square is equal. So by applying square for this one, what you get, square and root both will cancel. We'll get it as 1 plus dy by dx whole square. And next, so here it is, if you see that we need to simplify this one, so which is in the form of a minus b whole square, right? If you write a minus b whole square is nothing but a square plus b square is nothing but x square dy by dx whole square, and next minus 2ab minus 2xy dy by dx is equal 1 plus dy by dx whole square, right? Now you take all the terms into one side. So if you take all the terms into one side, there it is having, so x square dy by dx whole square minus 2xy dy by dx, and next plus y square, and here it is having right side terms, we are taking it left side terms, obviously the sign will change. Here it is having plus 1, when it comes to this side it changes to minus, so minus 1, and there it is having plus, when it comes to this side minus dy by dx whole square is equal to 0. If you see that first term and last term, if you see that the same term is available, right, which common term, so you take the common term from there. So if you take common term, dy by dx whole square is the common one, then we have x square minus 1 minus 2xy into dy by dx plus y square minus 1 is equal to 0. So if you take minus as common 1, obviously we'll get what you have here it is. So if you take minus as common 1, here 1 minus x square dy by dx whole square, and minus become plus 2xy dy by dx, and here minus of, if you multiply instead of that 1 minus y square, what you have here it is. So that one will get, if you take minus as common 1. So from this simply what we can say that now, which is looking like as a differential equation, now we need to write the degree of this particular equation, right? So the degree of that particular equation means what is the condition? First you need to see that the highest derivative, right? So if you see that the highest derivative, here it is having only first order derivative is the highest derivative, here dy by dx as well as dy by dx also we have, but the thing is what we said, highest degree in that, right? So here it is, if you see that the highest degree is for this is 1, and the degree is here it is having 2. In this 1 and 2, which one is the highest degree in that? 2 is the highest degree. So for that simply what we can write, degree is here it is having 2. So that is the one, like this we need to simplify this one. So degree of this differential equation, like this we need to solve. Okay, so which is already learned in previous classes like in your intermediate level. So here just for knowing that how to write the degree of that particular differential equation. So here next, if you see that the next example, there it is having a into d square y by dx square is equal 1 plus dy by dx whole square whole power 3 by 2. So this is the another differential equation. Now we need to simplify this one, right? So there it is having. So if you see that here it is having fraction we have. So what is the fraction here? It is 3 by 2. So 3 by 2 is the fraction. So for this, first we need to simplify this one. So for simplification, just you need to do that squaring on both sides. So squaring on both sides. If you apply squaring on both sides, here it is having this is a square, and here also we'll get it as a square, right? And there it is, if you see that ab whole power m is nothing but we can write as a power m into b power m. So like this, d square into d square y by dx square whole square. So which is equal, here it is having a power m whole power n we said. Here 2 and 2 both will cancel. And what you have remaining 1 plus dy by dx whole square whole cube, right? Now, like now we need to write the order as well as degree of this particular equation, right? So which is the order and which is the degree for this differential equation? If you see that the order here it is having d square y by dx square we have, and dy by dx we have. What we said, order is nothing but highest derivative, right? So highest derivative is nothing but here d square y by dx square is the highest derivative. So for this, here it is order is equal to how much? So order is equal to 2. After seeing the order, we need to see that the degree. So how to write the degree? Which one is the highest derivative of the highest power, right? Here if you see that this is having the highest derivative, this is having the derivative order is only 1, but we require the highest derivative. So highest derivative is nothing but here d square y by dx square. So the power of this d square y by dx square is nothing but 2. So for this we need to see we need to say about the degree is 2. So here order is nothing but highest derivative appear in the equation, and degree is nothing but highest derivative of the highest degree of the highest derivative. Okay, so this is about degree of that particular differential equation. Next, solution of a differential equation. So solution, or simply we'll say that root of a particular equation. In earlier classes already people learned what it means. Generally we'll say that here it is, suppose x square minus 2x plus 1 equal to 0. This is a given equation, and suppose we are saying that x is equal to 1 is a solution or root or 0 of that particular equation, we'll say that, right? So how we are saying that is a solution means a value which satisfies the given equation in the variable. So here if the variable is nothing but x, and we are giving a value for this x variable, so x is equal to 1, and by substituting that value in that equation it satisfies, right? So then we say that that is nothing but a solution. So in the same way here it is, we see that a function which satisfies the given differential equation. So for the given differential equation, if you substitute some function in place of y, then if it satisfies, then we call that is nothing but a solution. And we are dividing that solution into two types. Here it is having general solution and particular solution. So in the name only itself general, right? So here it is having BTech is nothing but general, and particular is nothing but, we can say that the course, right? So general is nothing but BTech in the sense in that it may be coming under CSG or EC will make branches will come. And particular, so particular is nothing but, if you are saying if you ask a student which branch you are, so then what he says, simply he says as CSG or civil or mech or EC, like that is coming under particular. And general is nothing but BTech. So in that anything it means there. In the same way here it is having general solution is nothing but a solution. This is also a solution coming under solution only, and particular solution is also a solution. So general solution is nothing but in that the number of arbitrary constants is equal to the order of the differential equation. Suppose if we are taking the differential equation, here I chosen dy by dx is equal 5. What is the order of this differential equation? Order of this differential equation is 1, right? And in the solution, one arbitrary constant is there. Suppose if we see that y equal to 5x plus c is the solution we are saying. In that c we are saying as arbitrary constant. So how many arbitrary constant here? Here only one arbitrary constant, right? If one arbitrary constant and the order is 1, if both are equal, then we'll say that that is a general solution of that particular differential equation. Okay, so that the solution which contains arbitrary constants is called general solution, we said. So obviously that is also we can say that, and the arbitrary constant is equal to the order of the differential equation, then we say that that is a general solution. And next, particular solution. So what we said as particularly, we can't change anything. If we a student said that is CSC, can you modify that one again? No, CSC means CSC only, right? So like that only. Here it is, suppose in place of arbitrary constant, what I chosen there, C. Suppose I write it as y is equal to 5x plus c, plus 5x plus 6. In place of not only 6, you can choose any number in place of c. So here it is 6 I chosen. If you see that, that's 6. So in that 6, can we change it anything in that? No, we can't modify, right? Once I fixed, in place of CS, I said 6. So it's fixed. So we can't change it, that one. So for that, what we'll say that is a particular solution. It means particular values we are giving to the arbitrary constants, right? So here it is the solution free from arbitrary constant. That is nothing but no arbitrary constant. In that, the solution obtained from the general solution by giving particular values of the arbitrary constants. So we are giving particular values to the arbitrary constants. Then we call that is a particular solution of the differential equation, right? So here in place of c, someone may give like 5 equal to 5x and minus 7. I chosen some value, and like that also you can choose some value. But the thing is, particular solution means it doesn't contain any arbitrary constant, right? As well as it's a fixed one. We can't change it anything in that. Once if you write it as some 7, can we modify anything in that again? No. So that is particular solution. These are the two things we are going to learn here in this particular unit, general solution as well as particular solution. General solution is nothing but it must and should, it consisting of the arbitrary constant, and how many arbitrary constants means that should be is equal to order of the differential equation. If the order is 1, then arbitrary constant must be 1. Here it is the first unit what we are going to learn, that is completely one arbitrary constant. Obviously what you have, only first order differential equation you have. In the throughout the entire first unit you have only first order. So obviously the constant, arbitrary constant must be 1 itself. If you don't write the arbitrary constants, then what will say that that is coming under particular solution. Why? Because what we said, particular solution doesn't contain any arbitrary constants. So that is the most important, general solution and particular solution if you are writing that. And next, formation of a differential equation. How to form a differential equation from the given equation? Like some equation they will give. So from that equation, how to form a differential equation? So for this, if you see that in general, an ordinary differential equation is obtained by eliminating the arbitrary constants C1, C2, C3 and so on, Cn. Here it is, we are choosing some equation. In that equation consisting of n arbitrary constants, and we are giving particular names for that arbitrary constants as C1, C2, C3, C4 and so on, Cn. N arbitrary constants it is having that, right? Suppose here it is for constant C1, C2, C3, n arbitrary constants we have. From this equation, how to form a differential equation? That is the important thing here. Suppose the equation having one arbitrary constant, that also we can form a differential equation. Two arbitrary constants, we can form a differential equation. Three arbitrary constants, we can form a differential equation, right? So based on the arbitrary constants, we get the differential equation. Here it is having what we said, differentiating one successively with respect to n times and eliminating the n arbitrary constants C1, C2 and so on, Cn, from the above n plus 1 equations. So n plus 1 equations, you may get dot here only n arbitrary constants means n equations. Not like that. No? Here it is already we have one equation, the given equation. And next what they are saying, differentiating one successively with respect to n times. It means how many arbitrary constants are there. Suppose one arbitrary constant, we need to apply one time derivative. Two arbitrary constants, two times derivative. Three arbitrary constants, three times derivative. Like based on the given equation, how many arbitrary constants are there? Those many of times we need to apply the derivative, right? So here two arbitrary is there, then we have to apply two times. And how many equations we may get means three equations. The given equation is 1, and next two arbitrary constants means we'll apply two times derivative. So obviously we'll get two equations, total three equations. That's why here it is having n arbitrary constants we have, n times we are applying. Already we have the equation here, one equation, right? So total n plus 1 equations. And next what they are saying, eliminating the arbitrary constants. Not only applying the derivative, after applying the derivative, we need to eliminate the arbitrary constants. It means finally what you are saying, the differential equation, it should not contain any arbitrary constant. So arbitrary constant should not be there in that particular solution what you are saying, right? So that is only here. Obtain a differential equation y is equal to a cos x plus b sin x by eliminating the arbitrary constants. So here it is having, if you see that this is the given equation, y equal to a cos x plus b sin x. And next here it is having two arbitrary constants, means what is the basic rule first, what we are saying, how many arbitrary constants are there, those many of times we are applying the derivative, right? So two arbitrary constants means we have to apply first one time derivative, dy by dx is equal to a is a constant and d by dx of cos x. So cos x derivative is nothing but minus sin x plus b into, here it is having sin x we have. The derivative of sin x is nothing but what will say that cos x, right? And next again we need to apply derivative, right? So let me take it as this is the given equation as 1 and this is the equation 2 we are saying, and you can choose another equation d square y by dx square. How we are getting this? Just by applying the differentiation of equation 2. Here already one time derivative. Again if you apply derivative for this, second time we are getting, right? D by dx of, so this is nothing but d by dx of dy by dx is equal, simply what we are write, d square y by dx square, right? So d square y by dx square is equal minus, so minus is there, so that minus we are writing outside, and a is arbitrary constant, we are writing outside, and sin x derivative is nothing but cos x plus b into cos x derivative is nothing but minus sin x, and let it be taken as this is equation 3. So first the basic rule over, right? What is the basic rule? First you need to identify the arbitrary constants from the given equation. After identifying the arbitrary constant, you need to apply the derivative. How many arbitrary constants are there? Those many of times we need to apply. Here it is having two arbitrary constants. So for that we apply 2 times derivative. And now we need to eliminate the arbitrary constants, right? So how to eliminate the arbitrary constants? So based on the problem and based on the equations we simplify that one. Okay, so there is no specific particularly like this way only you need to eliminate the arbitrary constants. Okay, here it is having, if you see that minus a cos x and minus b sin x. So here it is, if you see that which one is the common in that, minus is the common one. So I am going to take minus as common one from this, minus of a cos x plus b sin x. After taking the common one, just you can multiply this minus instead of the terms. The above one you got it or not, like that you can check it. Okay, so whether what you did the right or wrong, next step. So just by multiplying this minus instead of that, the above one should get it, right? Minus into a cos x is minus a cos x, and minus into plus is nothing but minus, and b sin x as it is. Now here it is, if you see that, can we use the first equation in place of this one or not? Our intention is to eliminate the arbitrary constants here, so minus as it is. If you see that the first equation what we have, y is equal to a cos x plus b sin x. So in place of this one what we can write, minus y we can write. Okay, so it means simply, did you get any arbitrary constants in that? No. And finally what we can say that the differential equation is, here it is having d square y by dx square minus equal to minus y, and take the term into left side, there it is having minus, when it comes to this side it become plus, plus y is equal to 0. Why? Because that side minus, and it side, this side, when it comes to this side plus, minus become plus, if it is plus there it comes to minus. So this is the differential equation of this particular equation. So like this you need to solve this one. If any arbitrary first you need to see that the equation, in that equation how many arbitrary constants, that one you need to identify. After identifying the arbitrary constants, you need to apply the derivative. How many arbitrary are there? Those many of times you need to apply the derivative. And next is simplification for elimination of arbitrary constants. Either you can use the determinant concept like. Okay. Next, first order and first degree differential equation. First order and first degree differential equation. This is exactly what you have till now what we learned. So from that we are going to exact syllabus what you have here. So first order and first degree differential equation is nothing but order, we know that, which is nothing but highest derivative, and degree also we know that, which is nothing but the degree of the highest degree of the highest derivative. That one we are saying as degree, right? So here it is having first order and first degree differential equation is nothing but what will say that dy by dx. So dy by dx is equal f of x comma y. So this one will say that the first order and first degree of a differential equation. So that only, here it is having the general form of first order first degree differential equation is f of x y y dash. So here in place of dy by dx we can use y dash also, right? So y dash. So y dash is equal to 0, or in this specific form we are saying m dx plus n dy equal to 0, where m and n are functions of x and y. So m and both are functions of x and y. So there is no general method to solve any first order differential equation. The equation which belongs to one of the following types can be easily solved. So like, we can't say that particularly we need to solve like this only, this method only need to apply, not like that. We have different methods for solving the differential equations based on the equation. Here it is, we have different methods. Here it is having variable separable, and second one homogeneous equations and non-homogeneous equations. And next homogeneous equations, and next exact equations, equations reducible to exact, and next one is linear equation and Bernoulli's equation. Like different methods we use for solving the given differential equations. In that first one, just we'll see that variable separable. So variable separable, in the name only itself, separating the variables, variable separable, separating the variables. So that only here first we are choosing first order, first degree differential equation. For all the methods what we said, all those methods we use this first order and first degree differential equation only. So dy by dx is equal to f of x comma y, and we are expressing that one as like dy by dx is equal to f of x by g of y, and by cross multiplying that we'll get it as suppose like this one, f of x. So what you get there, it is f of x dx and is equal g of y dy. By taking all the terms into one side, we'll get it as f of x dx minus g of y dy equal to 0, where f and g are functions are continuous functions of a single variable. Here by seeing that here x is one variable and y is another variable, it's a single variable, right? Then it is said to be of the variable separable. After separating the variables, so how to find the solution? So our intention is here to find the solution, right, for the given differential equation. But the thing is, if you are writing the solution means obviously that should consisting of arbitrary constant, right? So that is the most important. While you are writing the solution means it has arbitrary constant. So here it is having, if you see that, solve x square plus y 1 into dy by dx plus y square plus 1 into is equal to 0, y of 0 is equal to 1. So how to simplify this one? If you see that x square plus 1 into dy by dx, so x square plus 1 into dy by dx, and take the term into this side, minus of, there it is plus, when it comes to right side it changes to minus. And next we need to separate the variables, right? So for this, first we are cross multiplying that one. If you cross multiply that, x square plus 1 dy is equal minus of y square plus 1 dx. But if you see that here x variable and y variable, and here y variable and x variable, so we need to separate this one. So just you need to take that y variable this side and x variable that side. So when it comes to y variable this side, so it changes to 1 by y square plus 1 dy is equal minus 1 by 1 plus x square dx. Now if you see that, is it having variable separable or not? Separating the variable, we separated the variables, y variables as well as x variables. Now what is the next step? After separating the variables, what we did, just we are applying integration for this, right? Integrating on both sides. Integral 1 by y square plus 1 dy is equal minus integral 1 by x square plus 1 dx. So here it is having 1 by y square plus 1, integral formula 1 by 1 plus y square is nothing but tan inverse y. So this is equal to minus tan inverse of x. Constant should, what you need to write? Arbitrary constant if you are saying the general solution. And next take this term into this side, tan inverse y and plus tan inverse x is equal to c. Right? So here it is minus, when it comes to this side it changes to plus. So tan inverse y plus tan inverse x is equal c. So then this is general solution, but here it is one condition they give, y of 0 is equal to 1. We need to use that condition for getting the value of c. So there, for using this one, just if you see that which is in the form of y of x, right? Y of x is equal to y naught, y of x naught is equal to y naught, or y of x is equal to f of x. So here simply we'll say that this is the value of x and this is the value of y. Just you can substitute in place of x as 0 and y as 1. Then what you get? So tan inverse of, so y is nothing but 1 and tan inverse of 0 is equal to c. When in tan inverse, when it become 1, so we have tan inverse of, so tan pi by 4 is equal c. Why? Because tan inverse 0 is nothing but 0, obviously tan 0 is 0. And here from this simply what we can write, c is equal pi by 4, and substitute this c value in this one. So if you substitute in that, what you get? Tan inverse y plus tan inverse x is equal pi by 4. In place of this one we are substituting as pi by 4. So here if you see that, got it, that one, tan inverse x plus tan inverse y is equal pi by 4. Okay, so like this we need to solve this one, variable separable. So variable separable is nothing but separating the variables. After separating the variables, just only one step, we need to apply integration. After applying the integration, the mandatory thing is you need to write the arbitrary constant. And can you say that this is a general solution or not? Yes. Why? Because order of the differential equation is 1 and one arbitrary constant. Order of the first order differential equation is equal to one arbitrary constant. And next, of course, by using this condition, we call it as this one. So this is we call as a particular solution. Why particular solution means in place of C we are saying as pi by 4. So this is particular solution. So this is about variable separable. And next, so that one we use in that. And now coming to exact. So here exactly your syllabus starts from this exact differential equation. So condition is different and definition is different. So exact differential equation, what is the meaning of that exact differential equation is nothing but let m of xy plus dx plus n of xy dy equal to 0 be a first order and first degree differential equation. Suppose the given differential equation is in the form of this one, m dx plus n dy equal to 0. In that we are saying as m of xy plus n of xy dy, right? M is a function in terms of x and y and n is also a function in terms of x and y. So be a first order and first degree differential equation. Of course, throughout this unit what we are going to learn, the complete one is first order only. So for this, dy by d first order and first degree differential equation where m and n are real valued functions. Then when we say that this equation is said to be an exact differential equation, if there exists a function f such that dou f by dou x is equal to m and dou f by dou y is equal to n. So when we say that a differential equation is said to be exact means here it is having, we need to choose some function, right? So after choosing the function, that function has to satisfy the conditions. What are those conditions? Here it is having dou f by dou x is equal to m and dou f by dou y is equal to n, right? So if both should be same, then we say that that is a exact differential equation. Like suppose we can see the example here, x square dx plus 2xy dy is equal to 0. This is the given differential equation I said, right? So for saying whether it is exact or not, so first is this in the form of m dx plus n dy equal to 0 or not? Yes. So m is equal nothing but m of xy is equal to x square and n of xy is equal, simply we write 2xy. Now we have to choose the function, right? So for choosing the function is nothing but here we are choosing as f of xy is equal to x square y. This is the function I chosen. So for this function, what conditions has to satisfy here? First, if we apply partial derivative f with respect to x. So what's the difference for ordinary derivative and partial derivative? Here it is having with respect to what you are applying, that is only the variable. Rest of the one we should treat it as constant. It should be idle. So if I am saying about x only the variable and remaining all should be treated as constants. Here f with respect to x I am applying, right? So with respect to x I am applying is nothing but, so 2x and y is a constant and dou f by dou y is equal to what we get, x square, right? So here this is dx and now here it is having, so what we need to get here it is we are writing this is n and this is nothing but m. Here if you see that what we said, dou f by dou x is equal to m. So dou f by dou x is equal, m is nothing but 2xy or not, as per the problem what we said, m is 2xy and n is nothing but x square, right? So n is x square. So dou f by dou x is equal to m and dou f by dou y is equal to n. So like this, but by using the definition, solving the problem is little bit tedious. Why? Because there it is having, choosing the function is most important, right? Based on the choosing of the function only we check whether we may say that that is exact or not, right? So here that is exact differential equation. the next condition for exact. This is the condition we use for solving the problems. Here it is, condition for exact is nothing but if m of xy and n of xy are two real functions which have continuous real their partial derivatives, then the necessary and sufficient condition for the differential equation is to be exact if dou m by dou y is equal dou n by dou x. So when we say that a differential equation is said to be exact is nothing but if this condition satisfies. First we need to identify m from the given equation and n also we need to identify. After identifying that, we need to apply the derivative m with respect to y and n with respect to x. And if both are equal, then we say that is a exact. This is just for saying that whether the equation is exact or not. Why? Because we have different methods, right? Variable separable we said, homogeneous and non-homogeneous, like different methods we have, right? So here after identifying that this condition satisfies for the given equation, then we give the conclusion that equation is exact. Okay, we give the conclusion that equation is exact. After that, you need to find the solution for that exact, right? Our intention is here to find the solutions for the given differential equations, right? So that differential equation here it is, we said exact, and we need to write the general solution for that. So what is that general solution is we are choosing here? It is having, see here, so this is the solution we are choosing, like m of xy dx plus n of xy dy is integral m dx. M we need to choose as this, m we need to choose as this, and but we should treat it as, when you are applying integration, y should be treated as a constant, and next plus integral n dy is equals arbitrary constant c, and terms free from x in n are taken. While taking the terms from n here, we need to remove the terms which is having x. Without having x, whatever the terms are available, that terms only we have to choose as n. Okay, so here it is having equal to c. So like this we need to write that one. Okay, the solution is like this. And now coming to this one, so let us see the problem here. Solve dy by dx plus y cos x plus sin y plus y by sin x plus x cos y plus x is equal 0. This is the given differential equation. Now we need to find the solution for this, right? So first we need to write that equation is in the form of m dx plus n dy equal to 0. So dy by dx is equal minus of y cos x plus sin y plus y by sin x plus x cos y plus x, right? And cross multiply that one. If you cross multiply that, what you get? Sin x plus x cos y plus x into dy is equal to minus of y cos x plus sin y plus y into dx. Take all the terms into one side. Why? Because we require the form, right? Dou m by m dx. So first take this one into this side. There it is minus. When it comes to this side, it changes to plus. So y cos x plus sin y plus y dx plus sin x plus x cos y plus x into dy is equal 0. Now if you see that, is this in the form of m dx plus n dy or not? So this is m dx plus n dy equal to 0. So this one we say that m, and this is we say that n. Now we need to apply the partial derivative, right? So partial derivative we need to apply with respect to x as well as y. First we are applying m with respect to y, dou m by dou y. So m is nothing but what we said, this is m, and with respect to what we are applying, y we are applying. So if you see that the first term y cos x, so cos x is a constant and y is a constant, not constant, sorry, with respect to y we are applying. So for this here it is having dou by dou y of y is 1, cos x into 1 is nothing but 1, plus sin y derivative is nothing but sin y derivative is cos y, plus y derivative is nothing but 1, dou m by dou y. Next dou n by dou x. So dou n by dou x is equal n with respect to x. N with respect to x means, so with respect to x means sin x derivative is nothing but cos x, And next x cos y here. With respect to x, we are applying x derivative is 1 and y is a constant. So we are writing outside cos y and the derivative of x is 1. Did you get the same one or not? See here, cos x plus cos y plus 1, cos x plus cos y plus 1. So simply what we'll say that the given equation is exact. First we said exact, but we need to find solution. We need to find the solution here. So what we said for finding the solution here, it is having integral m dx plus integral n dy plus constant equal to c, right? Here it is having, we need to write that one, integral m dx. Integral m is nothing but, what about m we said? So m is nothing but, here it is y cos x plus sin y plus y into dx, m dx plus n dy. Here while taking n, what we said the condition here, terms free from x in n. Without having x, which terms available, that terms we have to choose. So without having x is any term, here it is sin x, x cos y and x term. So there is no x term available in that. So for that simply we will write 0 dy equal to c. If any term available, that term will write. If not, we don't write anything, right? So simply we write 0. So here with respect to x we are applying, and what we said y is a constant. So y outside and cos x integration is nothing but sin x plus, with respect to x we are applying, this is completely constant, right? So this constant we write outside, sin y plus y, and integral dx is nothing but x is equal constant c. This is the general solution of this differential equation. Got it, that one or not? Y sin x plus sin y plus y into x is equal c. So like this you need to find the solution of the given differential equation for the exact differential equation. Only two things here. The first thing is nothing but you need to convert the given differential equation in the form of m dx plus n dy equal to 0. After that you need to identify m and n. Next, apply the partial derivative m with respect to y and n with respect to x. If both are equal, then we say that that is exact. After saying the exact, next we need to find the solution for that exact differential equation. How we are finding the solution for the differential equation? Integral m dx plus integral n dy equal to c, where y is a constant and terms taken from x in n are taken. So this is equal to constant c. Okay. So this is the only these steps we need to follow for solving the exact differential equations. If it is exact, obviously you need to find the solution. Don't forget it for writing the arbitrary constant. Why? Because if you don't write that arbitrary constants, this is coming under, this is not coming under general solution. If you are saying general solution means that should be arbitrary constant. Okay, like this you need to solve the exact differential equations, and what we discussed, that is taken reference as is shown. Okay, and next remaining we'll see in next class.